All right. Good afternoon, everybody. I think we're going to get started. Glad you could all make it to this session on the last day of CIS, especially all sessions kind of after the big party are usually a little bit rough, but at least by 2:15 in the afternoon, most everybody's woken up. And we are here today to talk about the UMA 2.0 protocol. And we're assuming that going into this, we are going to be getting into some technical discussion here today. This is kind of one of the masterclass things. So we are expecting that you guys have a little bit of experience with things like OAuth and OpenID Connect and some idea of how these things kind of function and work going through this. If you don't have deep knowledge, that's okay. We're still going to be kind of talking through things and stuff like that. But all right, with that.
Well, hi everybody. I'm Eve Mailer. I'm with ForgeRock. Happy to be presenting with Justin today.
All right. I'm going to jingle without that. Hi, and I am Justin Richer. I'm an independent consultant. And looks like everybody's kind of filtered in, so I think we're good.
Yeah, let's get started.
All right. Hey, Jarvis, you there?
At your service, sir.
Fantastic. All right, I need you to load up the presentation for this afternoon, and let's get this thing going.
As you wish.
Because today we are here to talk about authorization.
In the age of UMA.
We are going to start out today. I'm sorry, there's a bit of a show in the second row here, but all right. We are going to start out today to talk about kind of an Internet of Things use case. So let's talk about Tony. Tony is our user for today. He is your average, everyday genius, billionaire, playboy, philanthropist, let's face it, like pretty much everybody that comes to CIS. We've got a lot in common here. And just like we do, Tony has a lot of devices that he wants to be able to manage. He wants to control access to them, he wants to be able to do stuff, and he wants to get access to them with his phone. Now, Tony's phone is a lot cooler than my phone. I really want one of those see-through phones. That's just sweet, right?
That's awesome.
It is. And but he's got some apps on his phone, and he wants to be able to access his resources, his devices, through apps on that phone. Now, the good news for Tony is that we have a protocol that can do that already. He can use OAuth to do this. He can set up access so that he, as the resource owner in OAuth parlance, can go off and say that, yes, you can go and, I can provision access to the client on my phone. I can delegate that so that this software can go do things on my behalf. And OAuth has, in fact, been moving into this device-based world. Even though it was written for kind of a web API and a web-based application type of space, OAuth has really been moving into the device-based world very strongly with things like the device flow extension, the Pixie for native applications, a lot of dynamic registration and discovery and management. OAuth does a lot of stuff in the sort of IoT and device space these days, which is really great. And that allows Tony to hook up his phone to his suit, and this works really, really well.
Now, meet Pepper. Pepper also has a fancy phone. Maybe not as fancy as Tony's, but it's still pretty nice. Tony's not the only one who needs access to all of his gizmos. Pepper occasionally needs access to them too. We know why. And Tony's actually a pretty cool guy. He's okay with that. Now, can Tony use OAuth to manage Pepper's access?
I mean, it seems like he should be able to, right? So OAuth is a delegation protocol. Tony's delegating access to Pepper in this case, so that should just work.
Well, actually, no. Because ultimately, OAuth is about Tony sharing with himself. What do I mean by that? Tony is the resource owner. That's what OAuth calls it. And OAuth is about a resource owner authorizing software to get access to protected resources. And, well, we know Tony has a lot of protected resources. And who's using that software? Well, Tony himself is using that software. Luckily, we can build what we need to do using OAuth. What is it that we need to accomplish? Well, we need to achieve party-to-party constrained delegated access. We need to achieve that constrain delegated access asynchronously, so Tony can say, well, let Pepper get access when she needs it, and we need to monitor and manage and revoke grants from some convenient place because Tony really, really likes convenience. Now, let's introduce Uma. Okay, not that Uma. User-managed access, although, in fact, the other Uma was one of the inspirations for the name, I have to admit. We mean the user-managed access standard from the Kantara initiative. Now, in fact, Uma does build on OAuth. How does it do that? It uses extensibility points that OAuth already has. It uses auxiliary specs like token introspection that we get from the growing ecosystem that the OAuth community has given us. And it actually uses the community itself. Now, in UMA, we call Pepper a requesting party, or RQP. Now, let's say that Jarvis is Tony's authorization server. Tony can instruct Jarvis to let Pepper in when she tries to access all of those fancy gizmos. Now, just like in OAuth, it's not actually Pepper directly accessing all the toys. It's actually her software that's directly accessing them.
Right, so how does that work? This is a technical talk, so we're gonna break things down a little bit. First off, Pepper software goes and talks to the API. In this case, this is the Iron Man Suit API. It is a RESTful API, obviously. And
standardized by IEEE?
Yeah, that is
Yeah.
an IEEE spec. Yeah, thank you. I forgot about that. And so Pepper's phone is going to go talk to Tony's API. Now, at this point, nobody really knows who anybody is. It's just Pepper's phone trying to make an access to this API. And this API has been protected by the Jarvis authorization server. So it's going to go talk to Jarvis and say, hey, somebody showed up, tried to ask me for access to stuff. I don't really know who they are or what's really going on, but I need something that will help me out to fulfill this request, or even let me know it's okay to fulfill this request. So it's going to get something called a permission ticket. Now, that permission ticket isn't good for accessing any data. It's not really representative of that. What it just means is that somebody asked for permission, and this allows us to hang together the next steps of the authorization process. Now, Tony's API knows to talk to Jarvis, and Jarvis knows about the API because Tony has set that up. He has set up a set of policies as the resource owner. Remember, this is Tony's resource. He has set up a set of policies that allows him to say, okay, yeah, if Pepper shows up, she can do this. If so-and-so shows up, they can do this, and they're allowed to do certain things and not other things. That's all at Tony's control. So that permissions ticket gets handed back to Pepper's software, which then goes and turns around and talks directly to Jarvis, and it says, hi, I need an access token. All right, I have this ticket thing, but I need an access token before I can go call this API. Can you help me out? At this point, Jarvis needs to know who's calling. In this case, it needs to know that it's really Pepper using that fancy phone in order for it to allow that phone access. So Pepper can do that by interacting with Jarvis and providing a bunch of claims. In this case, probably about her identity. Jarvis knows who Pepper is. He knows how to verify her and all of that. So she's going to prove that she's Pepper, and Jarvis says, hey, I've got a policy that says if Pepper shows up, she can do this kind of stuff. That's great. So now I can send an access token back to the client software that asked for it in the first place, which can then be used to call the API. And if this last bit looks a lot like OAuth, it really is. This is all built on top of the OAuth technology stack using a lot of the extensions that other specifications do as well. And now we're really sharing. Tony's able to delegate access from himself to Pepper using a stack that builds a little bit on top of OAuth.
All together now, everybody. Aww. So note carefully, we have two parties in this scenario. Tony is sharing with Pepper, and Pepper is not Tony. Now, what else might Tony want to do now that he can do this? He may want to actually put limits on Pepper's access. For example, he may want to keep her out of the beta class suits because we know they're kind of dangerous. He could decide that he may want to have her ask him first.
Sir, the telephone.
Because he may want to decide later to grant access. But what if he can't actually respond when called? What if he needs Jarvis to determine that it's really an emergency?
Right, so I mean, the theme of this conference is intelligent identity. This is a place where we can insert some intelligence into this process. And Jarvis could figure out here that, well, okay, I've tried to contact Tony, but I can't get in touch with him. And I know that it's Pepper that's asking, and I know that Pepper has this special access that if I can't find Tony and Pepper's asking for something, maybe stuff is really going down and I should let this go through. Right? This allows the policies to be very rich and very expressive. And we can handle more than just suits. In particular, UMA is able to handle not only different kinds of resources, but it's also able to handle lots of resources all at the same time, even if they're coming from different types of devices, different types of data sources. So let's say, for example, Tony wants Pepper to be able to access his medical information. Let's say that his blood palladium level is getting a little bit high, and he's kind of trying to keep an eye on it, making sure he's not dying. And he wants Pepper to be able to help monitor this because, let's face it, she's going to need access to his medical info. And more properly, he's going to need her to have access to his medical info, if we're really honest here. And so Tony can add that to his authorization server. He can say that these are extra resources, these are other resources that I have that I want to be protected by this authorization server. And I can set up policies that are separate from the suit access policies. When Pepper shows up, she can access the suits, but she can also access the medical information.
One of the things to notice about this is that the different kinds of resources may come from different resources entirely, and it may be that the Palladium level information may be coming from a resource server that had nothing to do with the suit resource server, and they can work with Jarvis nonetheless.
And this all works really well. But let's remember how Pepper managed to get access. She kind of logged in. Jarvis knows who she is. So Tony probably wants his medical information accessed by more than just, the close people around him. He probably wants his doctors to be able to do that. Now we could say that, Tony's a billionaire. He probably bought all of his doctors full time and made them hook up to Jarvis and everything like that. But, that's a lot even for Tony to manage, to be able to say, okay, like this person and set up all those accounts. He probably wants to be able to address sort of populations of users. Like any doctor at this practice is able to access my medical information and be able to, help me out in not dying, which is something that Iron Man really needs to worry about. So what if those doctors couldn't log in at all?
Meet Thor. As you all know, Asgard is really pretty big on security for good reason.
They've had a lot of practice at it.
Yeah, indeed. Now, Mjolnir is actually hooked up to the Asgard AS, and it really works pretty well to keep the bad guys out.
Yeah, it's got a pretty good track record.
I'd say so. Now, Mjolnir's resource owner wants to say that Vision is all right, and he can actually wield the hammer.
So, hang on a sec. So by Mjolnir's resource owner, that's Thor, right?
Well, actually, we're not sure. It could be Thor, could be Odin, could be somebody from way back. So it could be that Thor is just some downstream requesting party who's a Johnny-come-lately.
Oh.
Yeah. But, the Vision was actually just made. He's new. So he doesn't have an Asgard account.
And let's face it, he's not Asgardian, so they probably wouldn't give him an Asgard account.
It's true. He may never get one, ever. So, in fact, if you think about it, Pepper, when she proved her identity before, so unique identity is just one kind of attribute. You don't necessarily need a unique identity, you could have a non-unique identity. So this would work just fine. So once you do this, in fact, anybody, any class of parties who can fill your policy requirements can do stuff with your particular resource, be it a hammer or whatever.
And let's keep in mind here that even with the Asgard system, they still have a centralized AS. So all Asgard resources are hooked up to the Asgard 2.0 system there. And all of their policies and accounts and everything are managed and run through that. That works pretty well. But what if you don't trust a centralized AS? Because there's a school of thought that a global, centralized, all-powerful authorization system might be a bad idea.
Yeah, there's been this talk about autonomy and self-sovereignty lately. There's something about determining your own future,
Right. So let's talk about Steve. Now, Steve, as we all know, he works for S.H.I.E.L.D., and he's got a lot of cool gadgets and toys, but in particular, Steve wants to control access to his secret hideout. He doesn't want anybody just coming in here. This is a very special place to him. Now, Steve has access to an authorization server from work. And if you guys saw my talk on Shadow IT on Monday this week, that's something that I strongly recommend. If you have employees, allow them to access arbitrary resources and clients and get them hooked up to the corporate IT services. But Steve doesn't want to use the central AS for reasons. He doesn't want to trust it with everything. So instead, Steve's going to go grab a computer, something about his speed, and he's going to set up an AS that's running under his own control. Now, because this is Steve's own AS, he's got a lot of flexibility about how he can let people in. Now, in the Asgard system, we were able to say, if the person is worthy, they can wield this resource, and that's great. But that calculation of worthiness, that's entirely up to the Asgard AS. Right? You don't really get a lot of input into that. So if Thor were able to say, okay, no, I actually need vision to do this right now, he can't express that. There's no way for him to do that. Vision has to prove his worthiness independently to the Asgard AS. But since this is Steve's system, he's got a lot of choices. Now, S.H.I.E.L.D. could have a federated identity system so that when somebody comes up with an identity from work, they can log in using OpenID Connect or one of these other great standards, and that works really well. So Steve could say this individual person can go and do this. But as we saw with the vision, identity-based systems don't work for everybody. Because there are a lot of cases where the person that you're trying to let in, they might not even know what their identity is. So Steve has, because this is his AS, he's got a lot of other options. He could, for example, decide on a list of secret words. And in those secret words, he hands around to people, say okay, so when you're trying to access this stuff, just use one of these words, and you can go on, and it'll let you through. And notice that this isn't really a password in the traditional sense, because he's not asking people to log in and prove a particular identity, just that they have possession of this one secret. And just like in the Asgard system, Steve can decide on a particular set of arbitrary attributes that he can now calculate. And he can decide what those mean and how they are processed and what that means for his downstream policies. So everybody that he wants to have access to the system can get in, and consequently everybody else can't. And this even works because it's not all tied directly to individual identities, even when somebody's in disguise. This is a really, really great thing. Now, we have in the past heard of attribute-based access control, and we, of course, all have heard of role-based access control. Well, here at the Cloud Identity Summit 2017, we are debuting CRBAC, which is, of course, cinnamon roll-based access control. So for everyone who understood that reference, that's great. If you don't, you can blame Microsoft for this one. And if you want more of the story, come talk to us after.
All right, so this isn't actually fictional. Well, not entirely. UMA won't actually give you fancy armor, although it turns out that there's real-life IoT use cases that it could be applied to right now today. We see connected car use cases where the car itself kind of functions along with you as a payment system. We see consumer IoT and health IoT use cases where you can feed your health record from devices that are in you or on you or prescribed to you. And it won't give you see-through phones, I'm sorry. However, we saw only in the last couple of weeks that Android is now more popular than any version of Windows for getting connected to the internet. So there's that. But it will give you control over things. In fact, there are real-life APIs being standardized right now for health data sharing with patient control. In fact, my last talk was just about that. The Health Relationship Trust Group in the OpenID Foundation is standardizing security and privacy profiles for ensuring that these health APIs are being treated with respect so that patients can be treated with respect and they can share their health data in just such a way. And Justin and I are actually part of that standardization process. And these HEART profiles for OAuth and OpenID Connect and UMA and an API standard called FHIR are currently in implementer's draft status. Now, we're actually here today to talk about UMA 2, UMA 2.0.
Right. Anytime you get to the 2.0 in a system, that kind of tells you that there was probably a 1.0 and there were some probably reasons for going from 1.0 to 2.0. And since this is the introduction of 2.0, we wanted to talk about what those differences are and how we got there.
Absolutely. So we obviously learned some lessons from the 1.0, and that UMA 1.0 work started pretty long time ago. We learned lots of lessons along the way, and we found out what we needed to change by actually building things.
And in fact, one of the driving things that allowed us to a lot of insight on what needed to change for UMA 2.0 came from a project that my team was involved with about a year and a half ago now called Privacy on Fire, where we looked at the UMA 1.0 protocol and we saw all of the promise of this protocol, and we were like, all right, so let's go and build this out on a health IT system, and let's deploy this out on a demo. And it almost worked. It almost worked because we ran into a lot of the assumptions that were made with the UMA 1.0 protocol that weren't matching our use cases. Now, any standard, any specification has a lot of assumptions that go into it. Like Sarah even mentioned in her last talk, there's a lot of things that people think about, like, oh, this is how it's going to use, this is the environment that's going to be deployed in. Well, same is true with UMA as anything else. And it turned out that the way that we were trying to use UMA broke a lot of those assumptions. But we didn't just say, okay, this is broken and it needs to be fixed. No, we took a step back and said, what would we change in the UMA protocol? Like, what few things would we try and grab and twist around or edit or delete or add in order to make this work for what we were doing? And we built that. We built that as a proof of concept, put it on GitHub, and then brought that along with a very detailed write-up of all of the issues to the UMA working group and said, so yeah, we tried to use UMA, it kind of worked, and here's what we got out of it. And we weren't the only ones to provide that kind of feedback.
Yep, it was awesome. So what's in the 2.0? First of all, it's actually simpler overall. So let me give you a couple of examples. We actually changed the metadata discovery system for how you find all the endpoints by layering it right on top of the OAuth discovery spec. So that made a lot of simplifications right there. And we also made a ton of syntax simplifications, actually in the same vein, again, by looking at what had been built with UMA 1.0.
Yeah, we discovered as we saw more UMA 1 implementations, there were parts of the protocol that were being used a lot that you had to go 4 levels down into a JSON object to get to. And there were parts that were right up at the root that nobody cared about. Nobody was exercising them. And so with UMA 2, we were able to swap those bits around and chop things out where necessary. And it made the protocol not only sort of functionally simpler, but also syntactically easier to understand.
Yeah, we basically flattened and snipped some things. Second, it actually handles more use cases. So some samples of use cases that it was being used for initially included some things like, in the UK, there's a pensions dashboard profile that's been written that is a kind of insurance and government-to-citizen based use case. And actually in New Zealand, there's also a lot of government-to-citizen use cases around online resources. We also do see a lot of healthcare and healthcare IoT. Now, in this era, we're seeing more IoT use cases that can be served because of a need for disconnection. So previously, we required token introspection at runtime, and UMA 2.0 no longer does.
Now, one of the biggest changes in UMA 2.0, like I said, people were starting to use UMA in environments that didn't really match the assumptions and expectations of UMA 1.0. Well, UMA 1.0 had a promise of being able to, like Steve, bring your own authorization server, set up your own resources, and let anybody in with arbitrary attributes. And UMA had a lot of those pieces there, but it built it up in a way that made some assumptions that weren't really teased out until a little bit later on. So what do I mean by that? UMA 1.0 was built up on top of OAuth in a number of ways. And in UMA 1.0 and in 2.0, you can use OAuth to connect the API to the authorization server. This is all under the control of the resource owner, so OAuth works really well here. This is Tony's resource. He's able to say, okay, now take this and it's protected over here and I'm making that connection. It's all on my behalf. I can set up those policies. That all works really well. But UMA 1.0 also required the requesting party to connect the client to the authorization server. And that was all done through an OAuth 1 transaction, and at the end of that, you got the Authorization Access Token, or AAT. This was a special OAuth token that was only used in this part of the thing, and it was meant to represent that little triangle between Pepper, her phone, and Jarvis, that relationship right there. It didn't involve Tony or Tony's resources or anything out that end. The problem here is that this presumes that the requesting party can get an OAuth token from the authorization server. And if the requesting party can get an OAuth token from the authorization server, why are we jumping through all of these hoops of requesting parties and multiple things and tickets and redirects and all of this other claims stuff? If she can just get an OAuth token, can't we just do OAuth? Well, in Pepper's case, she probably could, to be honest, because she can log in. This works pretty well for Pepper. This doesn't work so great for the Vision because, like we said, he's probably not going to get an Asgard account. And honestly, this is pretty terrible for Bucky because he's not really going to be able to use identity claims in the traditional sense. And when he just wants to get access to the protected Plum API, he doesn't want to have to be able to identify himself in order to do that. So with UMA 2.0, we chopped out the AAT. But it turns out there was something the AAT did that was very valuable. It represented that little triangle of connecting Pepper to the phone and the authorization server. So we replaced just that aspect of the AAT with a non-OAuth token called the persisted claims token. And this PCT is issued by the authorization server so that when Pepper shows up and she does all of her claims against the authorization server is able to issue something that represents the distilled essence of Pepper, and hand that back to the client. That was enough of a polite chuckle. I'm happy with that, how that landed. And issue that back to the client. And what this means is that in future transactions, when the client shows up and it knows that it's still interacting with Pepper, instead of sending Pepper back to Jarvis so that she has to log in and do all this other stuff, it can just say, oh, hey, I'm still acting on behalf of Pepper. Here's my claims token. You figure out what that means and if that fulfills the policy. One of the cool things here, though, is that Tony's policies up there could reject any claims coming in from a PCT. He could choose to say that, no, I need, in order for somebody to do this, I'm not going to trust cached credentials or device trust or anything like that. I want to know that somebody is live and logging in and doing this. It allows you to address a lot of different types of scenarios. And so the PCT replaces the AAT, but you don't have to do OAuth in order to get it. That sequence that we went through of being able to just, go up and go get the tokens, you can get a PCT kind of as an artifact of that. And we also made security better than it was before. And like a lot of protocols, we made security better by deploying UMA 1 and figuring out what broke. There was a pretty interesting sort of corner case CSRF vulnerability in UMA 1.0, and we incorporated the fix to that into UMA 2.0 because we were able to take a closer look at the protocol and say, like, okay, so if we rotate this value here and hand this back and all that, then that'll keep an attacker from getting at things in that particular way. If you want details on that attack, grab me after the talk. And also, because we simplified the protocol overall, it made it a lot easier to understand what was going on, understand how things are working, and when you can understand things better, you can secure them better. You don't have as many moving pieces to keep track of, you don't have as many combinations of things that might go wrong. There's a lot more that you can do with the security.
Now, UMA used to be kind of more unified in version 1, but now it's kind of divided up differently. Before, we had the core specification, which was nearly everything, and there was a small spec called resource registration.
And, it pretended to be a separate specification, but...
Yeah, it thought of itself as a module, but it was actually a fragment. And so the UMA core specification did a whole bunch of jobs: getting a token, collecting claims, validating a token, connecting the client, and then we had this resource set registration specification, which just did the job of putting a resource under protection of Jarvis, of the authorization server. That's an important job, don't get me wrong, because it means let's say you have 10 different resource servers, one for each car manufacturer that Tony likes to buy cars from, and so on and so forth. But it's kind of not the whole story, and it's not a natural dividing line, in fact. So what we did instead in UMA 2 was a much more natural dividing place. So now we actually have an UMA grant spec. And we also have what we call a federated authorization spec. So I'll just spend a moment on that federated authorization spec, because the right side triangle that Justin showed, where we still have an OAuth token, that OAuth token represents the trust relationship between each resource server and an authorization server. Not everybody needs it, which is why there's a little dotted line.
Well, to be more clear, not everybody needs it to be dynamic. And in UMA 1.0, it was assumed that it usually would be. But it turns out that much like OAuth, people are deploying this in situations where you've got a tight coupling on that part, but you still want to have the loose coupling between the users to do cross-delegation and all of that other stuff.
Or perhaps a better way to say it is, it's just a private coupling, and you've got a private interface between them at times. And so the federated authorization spec is optional, and the beating heart of UMA, if I can call it that, is the OAuth grant type, called the UMA grant. Now, there's a lot of implications to writing an extension OAuth grant. The biggest one is that we've really simplified things. If you think about it, we have just made much greater use of the entire architecture framework of OAuth. We've simplified things on that basis. We've leveraged all the security consideration work that OAuth has done, the entire community, the entire specification work, and that is a big, big win. So that is one of the big implications.
Just another note on that point. UMA 2 is now using the same extension points for OAuth that things like the device grant that we talked about at the beginning, it's the same extension that uses. And UMA can now make use of things like advanced client authentication mechanisms or registration with software statements that were a lot harder to take advantage of previously with the way things were set up before.
Great point. So UMA itself, UMA 2, is just about done. This was the result of about a year's worth of editing, and we closed about, I don't know, 75 GitHub issues. That's how I measure things when I put out a press release anyway. We would still love feedback. Currently, we're in what's known as a public comment period at Kantara, and that means implementing feedback are very much welcomed. That period will close on July 12th. If you are curious about what implementations are out there, there's a number of industry and open source implementations being worked on right now. We invite more. And there's actually been some interest expressed in conformance testing programs and being listed as compliant. I think probably a little early for actual conformance testing, but interop testing is, we're probably at that stage of getting that going. So if you're interested in that or interested in putting in resources, please see me.
So in conclusion, UMA 2 is a fairly robust protocol to solve some really difficult and interesting problems. It tries to take OAuth into places where OAuth can't really go on its own. It tries to build things out and allow greater capabilities, and we really believe that with all of the effort that the working group and the implementers and everybody has done with UMA 2.0, we really believe that it can deliver
Avenger to Avenger sharing.
When they need it, even if you're not available.
All manageable through your very own Jarvis.
So now the question is, how do you want to use it? Just like OAuth, this is a security protocol. You're not going to implement and use a security protocol just for the sake of using it. Okay, maybe some people here in this room would do that. But normal people don't do that.
Well, I'd add, it's not just a security protocol. There are implications for privacy and regulatory compliance, not to mention trusted digital relationships.
Right, because you also do regulatory compliance for fun.
Totally,
right?
I do.
So you're trying to build something. If you have to comply with regulations, if you need security, if you want privacy, that's all because you're providing something. You're providing access to some API that's doing something. So now the real question that we have with UMA 2.0 is, how do you want to use it? What do we do now?
So with that, we thank you, and we'll invite your questions.
Thank you. All right, first question up front.
At the very end, you talked about the privacy potential for UMA 2.0. Can you comment on what, if any, influence GDPR had on the craft of the spec?
GDPR is much newer than UMA, but we didn't talk about the P word in the early development of the design goals. However, it's turned out to be extremely relevant. If you look at some of the key wording in the preamble, for example, I quote this a lot from GDPR, being able to withdraw consent without detriment. And there is talk in like the ICO consent guidance out of the UK talking about privacy dashboards and stuff. Being able to withdraw consent, being able to have choice and control, being able to have convenience, and being able to essentially have parity with organizations and businesses in the ability to manage your consent. Those things are really hard to achieve, and you look at the ICO consent guidance, and indeed, the entire GDPR is trying to wrest the meaning of consent back from what it's become, which is a checkbox, even an opt-in checkbox, where you don't effectively have control. And this is a mechanism by which a business could prove that it is actually not just doing data protection, meaning like preventing breaches, or just transparency, letting people monitor what's known about them, but actually giving some measure of control.
Thank you. Over here?
So I'm having trouble understanding what's the value of having the PCT as opposed to just the user doing whatever they need to do through the client to get the PCT and just giving them the access token at that point based on the policies right away.
Oh, that's actually a really great question, because like I said, my team drove the effort that eventually killed the AAT, and I was really happy with that. I was like, great, we don't need this, it's gone. And then actually it was George Fletcher from AOL who pointed out, like, that did something useful, and we just lost that. And that useful thing is, if you think of the case of the same requesting party going back to the same authorization server and asking for more and different resources. Now, if the claims that they have provided that first time, if those are sufficient for getting access to the other resources, then without the PCT in UMA 2, they would have to re-provide all of those claims every time they wanted to add a new resource, every single time. And if the client knows that it is acting with the same party, you know, it's a single device, or it's logged on to an account that is local to that, to that user, then that doesn't really, that's a really bad user experience, right? So say, for example, it's a doctor trying to get access to one patient's record, and then another one, and then another one, and then another one. Those are going to have different resource set identifiers, potentially different scopes. If the doctor is also trying to get access to an Iron Man suit for a medevac or something like that, you want to be able to differentiate those resources and the requests for those different resources. But you don't want the user to have to keep reproving themselves again and again. So what the AAT did, because it bound that little triangle tightly, because it made somebody do an OAuth transaction, that was a good representative that it's this user and this client talking to the AS again. So without the AAT, we needed something to represent that. The biggest difference between the two, and we didn't get into like the UMA 1 flows and things like that. The AAT you had to get first. So you had to go get an OAuth token, and then do the UMA thing, and then you get the UMA token. With the PCT, you just start by trying to get the UMA token, and all the stuff that you do to get the UMA token, you just do that like normal. If the AS decides that it wants to allow that particular client to do this sort of persisted claims trick, then it will, at that late point, alongside the access token, hand you the PCT. It's analogous, if you will, just a thought, it's analogous, if you will, to getting a refresh token so that you can go get another access token later. There are also refresh tokens in UMA, that's a different talk, but.
Yeah, I mean, the refresh tokens in UMA are the refresh tokens in OAuth.
Yes.
So we do actually have some swim lanes. Yeah, we have some swim lanes that illustrate the difference, and it's a subtle difference, and we have an UMA implementer's guide where I think we can put those swim lanes and walk you through them. So a URL that we didn't put in the slides, because it would have seemed gauche, is tinyurl.com/UMAWG. That'll get you to our homepage, from which you can find the specs, information about the public comment period, the UMA implementer's guide, the UIG, and I'll put a section in there that actually we'll also have something about that in the release notes, which I'm working on now. They're a little bit thin right now, but so we'll have information about sort of from the AAT to the PCT that illustrates exactly what the difference is. If you were to use a federated identity to log in, let's say you had somebody's OpenID Connect handle that you wanted them to log in with, it could be a really fairly subtle difference, but nonetheless there would be a difference if you say didn't want to disturb them with making them register for a login locally at the authorization server. That would be probably the biggest difference if you were wanting, if you had to force them to create a login that they didn't have before in UMA 1, you wouldn't necessarily, I think, have to ever do that.
Right. And another use case that I literally just thought of right now, so Eve will probably correct me in how wrong this is that, say we go back to Steve, and he's got that list of secret words. Steve could decide that once one of those words is used by somebody, he's going to burn it. One-time use, shared secret kind of thing. We see one-time codes like this all over the place. Well, instead of, for somebody accessing, the same person accessing the same, a new resource, or even accessing, different components, different scopes on that same resource, you could use a PCT to say, yes, this person has already given me a secret word, and I don't need another one in order for them to go do stuff.
Yeah, I've talked to some banks about use cases where you could have things like one-time codes on scratch cards, used as ways to hand out resources like, gift cards and things like that. Yeah, they just don't do it with a standard interface for protecting resources.
Yep, absolutely. We've got a question in the middle aisle here. Mic's coming around, and this is being recorded, so thus the mic. Thank you.
So first of all, I like the way you explained with the story. I really liked it.
Thank
So
you.
in your story, the Steve has a hideout place.
Uh-huh.
He got one tiny room. Let's assume he's a Trump, he got a big tower, right? You want to give somebody to access certain floors, but even though in the certain floor, I don't want to let you access certain number of rooms.
Mm-hmm.
Or maybe I access you the room, but don't access my fridge.
Mm-hmm.
Does UMA support such kind of permission authorization
So you want
checks?
to let somebody in your room, but you don't want them to steal your plums. Gotcha. And, right?
Right?
So I think we broke Laura. So no, that's actually a really great question, and that's one of the powerful things that both OAuth and UMA allow you to do in slightly different ways. OAuth allows you to express that kind of thing by having different scopes. So you could have the fridge scope and the room door scope, and so when you take your phone and put it up to the fridge, it gets recognized all of that. Go to the room, it doesn't let you in, or vice versa, or whatever. UMA allows you to take that a step further and treat the fridge and the secret room as different resources entirely. So OAuth doesn't really have a notion of a resource identity or a resource identifier. It's just OAuth is protecting an API, and an API could be made up of many APIs. OAuth really doesn't care. UMA does care, and it allows you to differentiate between those. So your policy, just like we talked about with Tony, having the medical stuff and the suit API, those are separate in his system. UMA allows you to do that at a much deeper and much more explicit level.
I'll give some color to that. So if you think about, well, Tony wants to grant access to his V8 Spider, R8 Spider, his car. I'm an Audi fan, sue me. And he wants to let, Happy drive the car but not access the glove box for some reason. As long as the manufacturer of the car makes the API available with that granularity, it's the controller, it's the API publisher. So it sort of has certain rights, and what UMA makes available now in the federated authorization spec, that presents a protection API. So Jarvis basically says, look, you can use this resource registration endpoint to tell me enough about your API so that I can ensure it's protected, but I'm kind of dumb with respect to what your resources mean and what your scopes mean. So as long as you tell me you have a resource called Glovebox and the operations are open, and that's like the scope on it, and you have a resource called, drive, and the operations are drive up to 60 miles an hour and drive up to 120 miles an hour, that's the grain of what can be done. And Jarvis doesn't know what that means. Jarvis just knows that Tony can now set policy according to that. So it's kind of separation of concerns because Audi's, it's the controller of what can be done with an R8 Spider. And Tony's in control of what can be done with his R8 Spider. And Pepper and Happy and whoever, Rhodey, are in control of only what access they've been granted for as long as Tony has granted it, if that makes any sense. Okay.
And now you guys know who the true Iron Man nerd really
Thank
is
you.
on this team. So, oops, I lost my mouse cursor. Here we go. I think we have a question up front. Yeah. Okay. We've got about 5 more minutes. So, yeah.
So you mentioned that the PCT,
The persisted claims token, yeah.
right, the PCT is bound to both the identity and the client.
Yeah, the requesting party and the client, yeah.
Okay. Given that there's now talks about token binding, is there any, and there seems to be that binding already in the PCT, is it not necessary, or should we be expecting that at some point token binding won't ever be applied to the PCT, or are those two, is one the same thing as the other?
They are not the same thing. So when I mean binding, I mean on kind of a more philosophical level of we've got these three different entities and they're kind of, their relationship is represented in the PCT. The token binding that you're talking about is on a much more cryptographic and technological level. And honestly, token binding for PCTs does make a lot of sense because it's only going between two parties. It's only passing between two parties, even though it's representing three. It's passing between the client and the AES. So if you have a token binding relationship between those, you're issuing it on the same channel that you're going to be using it. That is the use case that token binding was made for, is assuring that channel, when you're replaying that token, that it's the same one. And so it makes a lot of sense that we would see it layered on top of that. This actually does raise a really good question about, what about token binding and proof of possession and all of this other stuff that's kind of bubbling up in the OAuth world right now. What does that mean for UMA? Well, we took a very explicit, not our problem stance with the UMA specs, specifically so that we could inherit, and so a lot of us are involved in both spaces, but we wanted to inherit the good work that the that the OAuth community is doing more cleanly into the UMA spec. So instead of us trying to jump all over it and say like, oh, well, this is how you do POP with UMA, even though we don't quite know how to do POP with OAuth yet, and stuff like that. We just said, it's an OAuth token. If you can do OAuth token stuff with it, you can do that here too. All right. Anything else? I think we've got time for one more. No? All right, thank you all very much.